Okay, today we're doing another method of finding the limits algebraically. When there are radicals involved, we have to remember how to rationalize either the denominator or the numerator. In note card number 5, we did rationalizing the denominator. Okay, so you might want to pause and look back at that. For number 1, the denominator has the radical in it. The conjugate's going to be the same two terms, but the opposite of the last term. So instead of radical x minus 4, it's radical x plus 4. And then you do the same on top and you multiply. Okay? The second one, so when you multiply the top and bottom, by the way, on the top, you'd get 5 times radical x plus 4. On the bottom, instead of having to double, do the box, when you have conjugates, the middle two terms are always going to cancel out. So it's a shortcut that you just have to multiply the first two terms. Radical x times radical x is just x. And then the last two terms, negative 4 times positive 4 is minus 16. Okay? In the next one, there's a binomial here under the radical. So that's just the first term. Radical 5 minus x stays the same, and instead of minus 2 at the end, we're going to put plus 2. So we have to multiply the bottom by the same thing, the 5 minus x plus 2. On the bottom, let's just keep it x times radical 5 minus x plus 2 for right now. Let's focus on the top when you're multiplying the conjugates, that when you multiply the radical by itself, you just get what's underneath it, 5 minus x, and then the negative 2 times positive 2 is minus 4. So you don't need to do the box and multiply 4 times, because when you're multiplying conjugates, the middle two terms always cancel, and you'll see that in card 5 if you go back. Okay, we could rationalize to evaluate limits when we get an undefined value when using direct substitution. So just like yesterday, you had the option to factor and simplify. Today, there's going to be radicals, so you could rationalize either the numerator or the denominator. So this is card number 41, limits with rationalizing. The example's done for you. Okay? When you're using direct substitution and it creates a 0 over 0 situation, and you have a radical in either the numerator or the denominator, you could rationalize. Multiply the numerator and denominator by the conjugate of either, whichever one has. Simplify each portion, remove common factors, that's like what we did yesterday, and then find the limit with the remaining portion. So in this one, this box should be multiply. Okay? The conjugate of the numerator, which by the way we need to use, because if you plug the 0 in for x as is, you'd have a 0 in the denominator and it's undefined. So the conjugate of radical x plus 1 minus 1 is radical x plus 1 plus 1. So we multiply the top and bottom by that. When we multiply the conjugates, the radical times itself just gives you what's under it, x plus 1. Negative 1 times positive 1 is minus 1. On the denominator here, when it's not the conjugates, you could just leave it in factor form. The x times the conjugate, like right here. Because what happens is after you simplify the top, you're going to be able to cancel these factors if it's able to be manipulated like that. Now, there was an example in the homework last night also when it cancels like this and there's nothing left in the numerator, you have to remember to put a 1 in the numerator and the denominator is left on bottom. So when we plug in the 0, for the x in the new thing, you get 1 over 2. Okay, so take a screenshot of this and put it in your flip book for number 41. Let's do some practice examples. Number 1, again, if we were to plug the 25 in as it is now, we'd have a 0 in the denominator. So we can get the conjugate of the numerator, radical x plus 5 And on the bottom, radical x plus 5. So the numerator has the conjugate, so I'll multiply it out, and I'll get x, because the radical x times radical x, minus 5 times plus 5 is minus 25. The denominator, I'm just going to keep in factored form. The x minus 25 times the radical x plus 5. No need to multiply them out, because if you look, the same thing happens as that happened on the last example. The x minus 25 cancels. Remember, there's a 1 left on top. The radical x plus 5 is on bottom. And now we could use the substitution and plug the 25 in for x. So it's 1 over radical 25 plus 5. So we get 1 over 10. Okay, and if you look at the graph of this function in the calculator, you'll see that when x is 25, the y is 1 over 10. You might not be able to see it on the graph exactly, but you'll see that it's a very small value.